Equations. In algebra, an equation is a statement that says two expressions are equal. To solve for unknowns, we can rearrange the equation, but here's the crucial part. When we make changes to one side of the equation, we must make the same change to the other side. This keeps the equation balanced. For example, if we start with the equation 2 times x equals y, to solve for x, we would divide both sides by 2, which gives us x equals y divided by 2. This ensures that both sides of the equation remain equal. This principle is essential in problem solving. Whether we're calculating unknowns in algebra or making predictions in economics, we rely on this method of balancing equations. And that's exactly how we'll approach the Keynesian multiplier, which ties together many of the concepts we've discussed. The Keynesian multiplier. All right, everyone, let's conclude by tying everything together with the Keynesian multiplier. This is a fundamental concept in economics that explains how an initial injection of spending into the economy leads to a larger overall increase in income and output. The multiplier effect captures the ripple effect of spending through an economy, amplifying the initial investment. Let's work through it step by step, using our formula y equals I divided by 1 minus c. The equation we derived earlier, y equals I divided by 1 minus c. Y is the total income or output in the economy. I is the initial investment or spending. C is the marginal propensity to consume, MPC, which tells us what fraction of any additional income households will spend. 1 minus C is the marginal propensity to save, MPS, the fraction of additional income that households save instead of spending. This formula tells us that total income, Y, depends on two key factors: the initial investment, I, and the MPC, C. The higher the MPC, the larger the multiplier effect, because households spend more of their income, which circulates through the economy, creating more income and output. Let's quickly revisit how we arrived at this formula. We started with 1. Y equals C times Y plus I. This shows that total income, Y, is the sum of consumption, C times Y, and investment, I. 2. Rearranging, we get Y minus C times Y equals I. 3. Factoring out Y from the left-hand side, we get Y times 1 minus C equals I. 4. Solving for Y, we get Y equals I divided by 1 minus C. Now, let's apply this formula with some numbers. Suppose the initial investment I equals 100, maybe from government spending on infrastructure, and the MPC equals 0.8, meaning 80% of income is spent on consumption. Using the formula, Y equals I divided by 1 minus C. Y equals 100 divided by 1 minus 0.8. Y equals 100 divided by 0.2. Y equals 500. C is the marginal propensity to consume, MPC. So the total income generated in the economy is 500, 5 times the initial investment. This amplification happens because the money spent is re-spent multiple times through consumption, creating a cycle of economic activity. Let's think about this in a real-world context. Imagine a government invests £100 million to build a new bridge. The construction workers who are paid their wages spend that money at local shops. Those shop owners, in turn, hire more workers who spend their wages, and the cycle continues. With an MPC of 0.8, the initial £100 million investment generates £500 million in total income for the economy. Now, let's consider another example. A government stimulus program. Imagine a country facing an economic downturn where people are hesitant to spend money. To stimulate the economy, the government injects £200 million into the system by providing cash transfers to households. These households, now with more disposable income, spend a large portion of that money on goods and services. As businesses see increased demand, they hire more employees, leading to higher wages and even more spending. With an MPC of 0.75, this initial £200 million investment could lead to £800 million in total economic activity. This second example highlights how the Keynesian multiplier works not just in physical infrastructure projects, but also in boosting demand directly among consumers. It shows that government spending, whether through infrastructure or direct transfers, can stimulate economic growth, especially when people are less willing to spend on their own due to uncertainty. This is why the Keynesian multiplier is such a powerful concept, especially in times of economic downturns. By injecting money into the economy, governments can kickstart a cycle of spending, investment, and economic growth. In this lecture, we've seen how factorization in algebra helps us understand the ripple effects of spending in the economy. The formula y equals I divided by 1 minus c highlights how interconnected consumption, savings, and investment are and demonstrates the dynamic nature of economic systems. With this understanding of the Keynesian multiplier, you now have a powerful tool to analyze how government spending can influence the broader economy.